Okay, on problem 5D.
Can I go?
Yes, go. On problem 5D of Math Olympiad test number 5, we have a situation here where we have. Let me read the problem. It says, the Jimmy fills up a pool and he has a large and a small hose. The small hose would take 5 hours to fill up the pool, and the large hose would take up 3 hours to fill up the pool. And then it says that the small hose is turned on and allowed to run for 1 hour. Then the large hose is turned on, and both run until the pool is full. And the question is, how many hours did it take to fill up the pool? Okay, and so this problem can be, we're going to apply again the principles of understanding the problem, finding a pattern, being organized, and finding strategies. So the problem is very simple, okay? We can continue to use this principle of drawing pictures. Okay, we've been talking about that in class. So let's draw up this rectangle, okay? And that's going to be our pool, all right? And this is going to represent our pool. And so we're going to divide, we're going to divide this rectangle into little squares that will represent both hoses. So we're going to use both hoses, right? So one hose, it takes 3 hours. So we're going to divide it this way in 3. And the other pool is going to, the other hose is going to fill up this pool in 5 hours. So we're going to do it this way. So we can be organized. Okay, 1, 2, 3, 4, and 5. 1, 2, 3. Okay, and then let's compute some facts about this cube. Okay, we have how many squares? We have 1, 2, 3, 4, 5 times 3. We have 15. Okay, so we're going to say that the total amount of water to fill up the pool is going to be 15ths. Okay, so fill up 15 squares over the total number of squares, 15, over 15, right? And then what other facts do we know? Actually, let's do that. Okay, then this is the first fact. The second fact is going to be that the small hose fills up the pool in 3 hours. Okay, so in 5 hours. So we would fill this much of the pool. We would fill up this much of the pool in 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, right? So that would say 5 hours, 1/5, right? Or 3/15, correct? Because it would be 3 squares in 1 hour. So the small hose by itself, okay, it fills up 1/5 per hour, okay? Or in this case, because we're representing the pool by this square, it would be 3/15, okay? 3 out of 15 squares per hour. All right. Then we're going to say that the large hose, actually, you know what? Let me represent small hose and large hose. It's going to be 1/3 or 5/15, because the large hose is going to do I'm sorry, 1/3. Trying to rush, guys. Alright, don't rush. Okay, because it's going to do that much, the large hose, right? So this side would represent the large hose, and this side would represent the small hose, correct? So, so 1/3, the large hose will fill up the pool 1/3 per hour. In 3 hours, 3/3, which is the total amount of water, or in this case, is going to fill up 5 squares of the total amount of 15.
Get the robot.
Quiet, quiet.
I get the robot.
Go. Okay, so let me put this. So this represents the large hose, and this represents the small hose. Small hose. Okay. So that gives us a pretty good picture of what is going to happen here. So let's look at this part of the problem. It says that the small hose is turned on for 1 hour. Okay, so let's look at the 1 hour. Okay, so in the first hour, the small hose is turned on. Okay, so how much water was filled up? Well, it was filled up this much, 3/15, correct? In the first hour. So let's write it down. First hour, 3/15 of the pool were filled up. Okay, so then in the second hour, the second hose is filled up. All right, so on the second hour, we have the small hose. Okay, the small hose filled up another 3/15. Okay, but also the large hose filled up how much? Let's pick that color. The large hose fills up 5/15. Okay, so 3, 4, and 5. Okay, so let's see if we okay, Papa. So this much of the pool was filled up in 2 hours, right? And so that would be plus 5/15, right? And this would be what? It would be 8/15. So and that just happened in the second hour. But the second hour is obviously 1 hour, right? So let me color in red here that this much of the pool was filled up in 1 hour with both hoses running. Okay, which is how many? The noise. which is 1, 2, 3, 4, 5, 6, 7, 8, right? 8/15 in 1 hour. So let's write up another fact that in 1 hour, 8/15 of the pool was filled up. So the question is, how many squares do we have left to fill up, to completely fill up the pool? That would be 1, 2, 3, and 4. So we have 4/15 of the pool left. Okay, so the question is, how long will it take? Well, if 8/15 were filled up in 1 hour and we only have 4/15 left, okay, we're only looking at the numerator here. That means we have half the amount of water to fill up. So I apologize about the noise, guys. But anyway, so if we are filling 8/15 of the pool with both hoses running at the same time in 1 hour, then in order to fill up 4/15, okay, at the same rate, we would need only half an hour.
Dustin and Jaden are here. Dustin and Jaden are here.
We will need half an hour. So the answer is that it takes, it's going to take 2.5 hours to fill up the pool. All right, thank you.